So you still remember the difference between series and sequence. You can refer back to slide 11 and 12 if you cannot recall. Anyway, let's do a quick revision. Starting with a sequence, geometric sequence with terms A, AR, AR squared, AR cubed, and so on. If you add all the terms of a sequence, of this geometric sequence, you get a geometric series. And because you sum infinite number of terms, we talk about sum to infinity. And we are going to deduce this conclusion. Sum to infinity, as infinity, is A over 1 minus R, if R is between minus 1 and 1. If R is less than or equal to minus 1, or R is more than or equal to 1, means the sum to infinity does not exist. If the sum to infinity exists, then we say that the series converges. So if sum to infinity exists, series converges. And eventually we conclude that for geometric series, you need R to be between minus 1 and 1. Recall that previously we have derived a formula for Sn. It's A 1 minus R, A over 1 minus R, bracket 1 minus R power n. So you'll find that Sn depends on R power n. And R is not equal to 1. And if you choose a value R between minus 1 and 1, let's say 0.9, and 0.9, and then you raise it to power n, you'll find that you get smaller and smaller. You can try it out. If you consider 0.9 squared, you get 0.81. If you try 0.9 cube, 0.9 cube, you get 0.729, is even smaller. So you'll find that when n get large, n large, then R power n will tend to 0. It becomes very, very small. So with that, we see that when n is large, when n tends to infinity, Rn tends to 0. So the factor 1 minus R power n will tend to 1. So which means this part will become 1. So you left with A over 1 minus R times 1, which is A over 1 minus R. That's how we get sum to infinity is A over 1 minus R, under the condition R is between minus 1 and 1. If you choose a value of R less than minus 1, less than or equal to minus 1, or more than or equal to 1, you'll find that R power n get bigger. So you cannot find sum to infinity. Previously we consider a segment with length 1. Right? So this segment is length 1. So from here to here is length 1. Then you cut half on the first day. So you cut half on the first day. Now the second day you cut half of half. You cut another half of half, which is half square. And then third day you cut half of half square. So it's half cube. Right? So every day you cut half of the remaining. Until 100 days, the piece you cut out, the length will be 1 over 2 power 100. And notice that this will give you a geometric series with first term half, R equal to half. So if you type inside the formula, Sn is A over 1 minus R, you get 1 minus 1 over 2 power 100. And in general, if you look for Sn, Sn, you sub A as half, R as half, then you find that you should have this part. 1 minus half is half, so half and half cancel. So we just give you 1 minus 1 over 2 power n. And you see that this one will give you 1, will tend to 1, because 1 over 2 power n will tend to 0. 1 divided by 2 power something big will give you 1 divided by a big number, so it gives you a number near to 0, which is 1. And it's correct because you started with a segment of length 1. So no matter how many times you cut, and most you get is length 1, the whole segment. Next, we are going to look at rational numbers. A rational number can be expressed as p over q, when p and q's are integers and no common factors. We are going to write recurring decimal into rational number, meaning fractions. Recurring numbers decimal are decimal of the form like this. You keep repeating the digit after some times. So for this one is 0.321, 321, 321, 321, and so on. And you want to write it as rational number or fractions. So you can rewrite it as 0.321. And after that, this 3 decimal is 0.000321 is here. Then this 3 decimal 321, in front you have 6 zeros, so it's written here. Okay, so with that, you see that you get a geometric series. The first term is 0.321, and the common ratio is 0.001. You keep multiplying by 0.001, you get next term. And recurring decimal is never ending, so it's an infinite decimal. So the first term is 0.321, the common ratio is 0.001. So applying the formula a over 1 minus r. Remember, we just divide the formula. A S infinity is a over 1 minus r. So you apply this formula. And you sub in your a, which is 0.321, and r is 0.001. And after that, you can move that 3 decimal here. Move 3 decimal here. So it gives you 321 over 999. And then you divide by 3 to give you 107 over 333.